going to trusses. Do you have any questions regarding the equilibrium beams and all that? We should do one question with the. Four, and you have 3 questions with the four topics. Do you want to do one more equilibrium question? Okay.
Similar to the Cartesian.
Similar, but if you have a fixed support, then you have to have 3 unknowns. Okay, so we have if we have time, we'll do some more questions. Okay, now we are going to do trusses. What are trusses? Where do you see trusses? No, it's not a truss. Trusses are long, thin members. You see roof trusses. Have you seen roof trusses? Yeah. And the bridges, they are truss. You have long, thin members. So truss, in trusses, you need to find, analysis of trusses means you are going to find the internal forces of truss members. Why we need to know whether these truss members, some truss members are under tension, some truss members are under compression. Okay, so you need to find the internal force, whether it is 20 newtons or something, and whether it is a compressive member or a tension member. Why we need to know this? These are need for civil engineers mostly, maybe mechanical as well, because you have machine parts and all that. Why we need to find this information? Analyzing trusses, and we find the, why we need to find those support reactions and all that in the previous ones. Otherwise your buildings and all that will, like, they won't stay, isn't it? So even for trusses, why we need to know these things? To find the right material to use, because you need to know how much force this should be able to hold. So you need to select the right material and also the right thickness. Am I right? When you have, they are long, thin members. Tensile member, the thickness of a tensile member and the thickness of a compressive member is different, even though the same force. Why is that? It's not only the force, it is important to know the compressive or tension. Why? When you have long, thin member, when it is compressed, it can buckle. So we should prevent the buckling. So normally we use a thicker members for compression and thin members for tension. Okay, now let's move to a question. Okay, we have a truss here, and we need to find the member forces. So there are 2 methods, method of joints and method of section. So we'll start with the method of joints. So in the method of joints, in a truss question, first thing is again considering the equilibrium and finding the support reaction. So here the support reactions are already given to you. But if it is not given, do you know how to find the reaction forces? How do you find it? You draw the free body diagram of the truss. So this is the free body diagram of the truss. So I'm going to draw the free body diagram of the truss. And we have the force 600 here. And here we have what? Pin support. Am I right? So pin has A, Y and AX. And here we have a roller support that will have BY. Now considering this one, you have to find, applying the conditions of equilibrium, you are finding this one. So what you do? You can consider all the forces in x direction, only one force, and it is equals to 0. Am I right? If you take the moment about this point, 600 times 3, am I right? Negative plus by times 4 is equals to 0. Am I right? So you can find by, they have already given us it is 450. And if we find it, we should get the same. 600 times 3 divided by 4, which is 450. And also you can find AY, considering all the forces upward. AY plus BY minus 600 should be equals to 0. So you can find AY, which is 600 minus 450. They have given us 150. Okay. So if the inner truss question, if the support reactions are not given, are you guys okay to find the support reactions? Okay. Okay, now in this one, the support reactions are given. So we already found it. Now we are going to use the method of joints. In the method of joints, what we do is we consider the joints. We separate the joint and the member. So where are the joints? You have a joint here, you have a joint here, and joint here. Okay, I'm considering the joints only now. And the members, I'm separating the members. I'm doing this because this is the first question. You don't have to do all this stuff. Just to explain. Okay, so I separated the members and the joints. Now we consider, I don't know what the teacher said. I normally consider all the truss members are under tension at the beginning. I assume that. Did you do the same thing or not? Tension? Okay, let's do this way. Okay, if you have another way, that's fine. So, okay, so I assume all the truss members are under tension. So tension means what? You have tension like this. If there is a tension like that, always from at the joint towards the member, it is going out. Arrow is going out. Am I right? So this one arrow going out, and this one also arrows going out, going out. Am I right? They all arrows are going out. Then only everything is under tension. Make sense? Am I right? And we need to put the support reactions, which is 150 here, 450 here, and 600 here. Am I right? So you consider one joint at a time, and I'm considering joint A. So if I consider the joint A, I have 150 going this way, and I have a tension T1. I'm considering this one as T1 and this one as T2. If this is T2, this also T2. If this is T1, this also T1. Otherwise, it won't be in equilibrium, isn't it? And this angle is 33.7. It's given. So this is a particle which is under equilibrium, isn't it? So you have already done this question. So how do you find T1 and T2? If you consider this equilibrium, if you find the components in the y direction, it should be equals to 0. Am I right? So that means T2 sine 33.7 plus 150 should be equals to 0. Do you agree with that? So you can find T2, which is negative 150 divided by sine 33.7. So you have a number here in newtons, and you have a negative sign. What the negative sign says? I assumed it is in tension, but I got a negative. That means my assumption is wrong. So this member is under compression. Make sense? So I did T2. Can you consider the forces in the x direction here? Find the forces in the x direction. T1 and a component of this is equals to 0. So can you find T1, please?
Why we write the T2 at the place of A?
You mean this T2?
Yeah.
Okay. What I did, I separated the member and the joint. When they are together, T1, these two forces here will cancel out when they are together because they are opposite.
Yeah.
But when I take them out, one T2 is in the joint, the other T2 is in the member. So when I consider the joint, this T2 should be there. Make sense? Same thing here. This T1 is not there when they are together. Now I'm separating the joint and the member. So member is under the tension T1, and the opposite reaction from the joint to the member T1 is at the joint. This one is here. So T2 is the member force along AC, and the T1 is the member force of AB. Is that B? No, this is D. AD. That's what the question is asking us, to find these member forces and whether they are under compression or tension. So your question is why I put the T2 now? Yeah. Do you understand why I put the T2?
Yeah.
Okay. So while you're doing that, I'm just mentioning the T's, otherwise we forget the T's, okay? So these are the T2, and this one I put T1, and I'm going to use T3 here, and this one as T4, and this as T5. Okay, when you find the T1, let me know.
T2 is negative 270.
Yeah, negative means compression, okay?
Compression.
Yes, so 270 newtons compression.
Yeah.
So member AC is under compression.
T1 is going to be, we want to find T1.
Okay, so we are considering the joint A, and we already found T2, and we need to find T1. So this is the equilibrium of joint A, considering the equilibrium of joint A. So T2 we found negative 270, right? Okay. And we have 150. Okay, now when you consider all the forces in the x direction, we wrote T1 plus T2 cos 33.7 is equals to 0. So T1 was T2 negative T2 cos 33.7, isn't it? So T2 is what? Negative 270, am I right? Yeah. Now when you substitute, you need to substitute with the sign, okay? So if you can't just substitute the number, you need to substitute with the sign. So T1 is a positive 270 cos 33.7. Agree? So what the positive says? This is under 220? 4.4, 224.6. Okay. This is under tension. Okay, so this member is under tension and this member is under compression. Agree? Okay. Now go to the other joint now. So which joint you want to do now? So this is T1 and this is T2. T2 and this is T1. Which numbers I said? This one T3 and this is T4 and this is T5. Okay. Now going to the other member. Which member you want to do now? You have to select members. Which joint you want to do? Joint with only two unknowns, because you only have two equations, x direction and y direction. So which joint? We can go to the joint D. Are you happy to go to the joint D? Okay, so I'm going to write the joint D. So this is consider the equilibrium of joint D. So this is D. So in this direction I have T1, this direction I have T4, and upward I have T5. Okay? Alright. Now, tell me, apply the equilibrium conditions and find me this one. So what is T5 and what is T4? Find this, please. Yes, T4 is equal to T1. Do you all agree with that? So what was T1?
It was 224.6.
Positive, and our T4 also under tension because you have a positive value here. How about T5? 0. So it's a zero load member. There is a way of identifying zero load members. I will tell you that later on. Okay, you don't have to do the calculations to find it. There is a way of finding them at the beginning just by looking at the picture. I will tell you later on. Okay, T5 is 0, T4 is 224.6. Now we have two more to find. We haven't, no, one, just T3, isn't it? So you can either go to B. So let's go to the B now. So if I consider the equilibrium of joint B, can you draw the forces now? How you draw the joint B? Joint B, yes. Do I have to draw the 450? Yes, it is 450. Then what should I have? All the other arrows are going out from the joint. Why are they going out from the joint? I assume them as tension. It is my assumption, but if it is wrong, it will give a negative sign. So this is 63.4, and this is T3, and this is T4. Am I right? So we already found T4. So if we consider the forces in the upward direction, we can find T3. What is the component of T3 upward?
T3 sine 63.54
Plus 450, because both are upward, right? Is 0. So you can find T3, which is negative 450 divided by sine 63.4. Negative means that member is under compression. Why? We assumed everything under tension. Any negative number represent a compressive member. Only thing is, when you are substituting, you need to substitute with the negative sign. Yes. Okay. Minus 503 newtons, and it is under compression. Are we good? Okay, so this is method of joints. Yes, so if you have in the previous one, do you remember? We had to find in this one, when we do this one, we had to T1. When you finding the T1, you had negative T2 something. So when you are substituting T2, you substituted with its sign. So if you have to substitute T3, you substitute with the negative sign. Make sense? Okay. Can I move to the next question? I don't want you to read the question, but I want you to find the support reactions. Oh, it's too easy. Find the support reactions and the member forces. I'll give you time. You need to, what components?
like A by or B by or C.
Yes, they are not components, they are your support reactions.
Okay.
Yes, you need to find the support reactions. Yes, but in this one, support reactions is really easy. You don't need to, you just by looking at this, you can tell me that. Can you tell me? 8 each. Why? This is a symmetric question. 60 no horizontal load, all symmetric. So this 16 should be equally divided. So this one should be 8, and also this one should be 8. You don't need to calculate it, yes, because you don't get this kind of questions. You should be very lucky to have something like this, but yeah.
But we are not getting this.
You didn't get this?
We had
You had the same question, right?
Yeah, the same one.
Did you get the 8 or not?
Yeah, the exam.
Okay. Okay, now the rest. So you have 3 members, you need to find 3 member forces. Consider one joint at a time. So when you consider joint A, now you don't need to draw all the things, okay? Consider the equilibrium of joint. So you can write that. Consider the joint A, equilibrium of joint A, something. So what are the forces acting here? You have 8. And you have this way, let's say this is T1, T2 and T3, okay? T1 like this and T2 like this, and this is 60 degrees. And can you find me T1 and T2, please?
T1.
You found T1 first. But you have to find T2 first, because otherwise you have to consider the forces in the Y direction.
Actually, I find the T2.
Okay. So T2, how did you find it? T2 sine 60 plus 8 is equals to 0. So T2 is equals to 8 divided by sine 60. Negative. So that will be 9.23 newtons, kilonewtons, and that member is in member, what is it? Member AC is under compression. Okay, you need to write it, because I told you at the very beginning, it's important to know whether it is tension or compression, because compressive members we need to make it bigger, otherwise that will go on buckling. How about the other way now?
There's no AY.
What's that?
There's no AX.
No, because why? If
No
you
X,
no, there is no force in the x direction.
what about T1?
T1 you have, because you have here, when you consider the joint, you consider the forces in the x direction. T1 plus T2 cos 60 is equals to 0. Ax, you find the Ax considering the equilibrium of the truss. You can find it if you want to find it and tell me Ax is what? It's 0, isn't it? Why it is 0? Because when you consider the truss as a whole, there is no force in the x direction. So Ax is 0, isn't it? Even in the previous one, pin support. Makes sense? Okay, so what is T1 now? T1 is negative T2 cos 60. So it is negative. Now you need to substitute with the negative 9.23. Do you get me? Okay. So you have a positive something. Positive means positive means what? Member B is under tension. 4.6 kilonewtons. Okay, one more member to find. You can either consider the joint B or C, equilibrium of joint B or C, and find me T3. And T3 magnitude and whether it is under compression or tension.
It's going to be the same.
Yes, it should be same as T2. Why? Again, equilibrium.
Yeah.
So your T3 is also what? Negative 9.23. It is under compression. Why? You can, it is just symmetric.
Show me how AX is 0.
Ax is 0? Okay. I'm not going to do it. I want you to do it. Okay. So we are drawing the free body diagram of this. So when you draw the free body diagram, you have a pin support. Am I right? So this one you have AY, AX. And this is a roller support, so BY only. Okay, now consider the equilibrium of this and write the equation for forces in the x direction. What are the forces in x direction?
So for this one, we don't care about the truss.
You care about the truss, you consider the whole thing, yes. So do you have any force except at AX? You consider the whole truss. Your free body diagram is the truss. Do you have any?
Consider the T1.
No, because till when they are together, they are actions and reactions. When you take them off, only they are two separate loads. They are internal forces.
Outside force.
Yes. Till you keep them together, internal forces won't affect. So they are actions and reactions.
This one is the action.
We can't say that. Which one?
I get it now. I understand.
We don't have any horizontal forces, so it's going to be 0.
Yes, so Ax is 0, isn't it? Ax is 0, but you can't say there is no force in this member. You can't say that. Because when you consider the joint and when you separate the members, there can be member forces, internal forces. They are internal forces. Got it? Okay, when I'm standing, I'm stable. But like, if I consider myself alone, there is a weight acting on down. So I should go down because of the reaction from the floor. I'm staying here. But together, there is no resultant force. My weight and the reaction is equal, so that's why I'm standing here. Likewise, when you have the joint and the member together, they are cancelling out. But when you take them off, you need to draw them. Make sense? Okay, are we good? Can I move to the next one? I'm going to do the method of sections, okay? When you have a big trusses with many members, method of joint is not easy to find just particular member force, because you have to go by every joint and find it. But yes, so in method of sections, what we do is you can section the beam. So let's say what this says. Before that, I want you to know zero load. I will let you know later on. Yes, zero load members, how to identify them, I'll tell you later on. Because here there are some zero load members. You find it. You can find it by yourself. Let's see. Okay. First, can you find the support reactions for this one? A and C. A is a pin. So if you draw the free body diagram, A is a pin. So you can put AY and AX. Again, AX is 0 because CY. Okay, can you find me this ones, please? I'll give you time. AY, CY and AX. Easiest way of finding this is taking the moment about A. Am I right? When you take the moment about A, you don't have this one, or this one. You have this way, and this one other way around. Am I right? So CY times 2.4 minus 4 times 1.2 is equals to 0. So your CY is 4 times 1.2 divided by 2.4, which is 2. 2, am I right? Is that right? Okay. So this one. So now you consider all the forces in y direction. You have AY minus 10 minus 4 plus CY is equals to 0. So your AY is 14 minus 2, which is 12. Did you get this or not? Yeah. Okay. All right. 14 and 2.
AY is equal to minus 16?
No. So AY is this one, right?
Yep.
So when you consider all the forces in the y direction, you have AY minus 10 minus 4 plus CY is equals to 0. Am I right?
Yep.
So AY is 14 minus CY, which is 14 minus 2, which is 12. Am I right? So is that right? Right or wrong? Okay, so this. Okay, so let's say this one. This one is 12 and this is 4, right? Sorry, 2, right? 2. Okay, now what they ask you to find, method of EF. EF is this. EA is this, and AB is this. Okay, so they're only asking you to find these 3. You can do it in method of joints as well, but we are going to do it with method of sections to know how to do with the method of sections. So in the method of sections, what you do is you section in a way that the section goes through the members that you want to find the member forces. Okay, so you are cutting it. You have to decide where to cut depending on what you want to find. So I want to find these 3 members, so I'm cutting at that point. Make sense? Now you can either consider the left hand side or the right hand side. It's up to you again. It doesn't matter which side you consider, you still get the same answers. Okay, so I'm going to consider the right hand side. So if you consider the right hand side, this is what I have. Now it is not a particle question, it is a rigid body question. So this one I am taking T1, T2 and T3. So this is T1, this is T2 and this this one is T3. Again, when you put the arrows, how you put the arrows? I consider arrows going out. Why I'm considering arrows going out? I assume they are under tension. In case we get a negative sign, that means it's compression. Okay, so this angle, we don't know the angles now. We need to find this angle. So how do we find this angle theta? Tan theta, if you write the tan theta, opposite is what? Opposite is what? This one. 0.9. Adjacent is what? 1.2. Can you find me theta, please? Okay, 37 degrees. Okay, now you have a rigid body. What are the equilibrium conditions you can apply? All the forces in the x direction should be equals to 0, y direction should be equals to 0, moment about a point should be equals to 0. You need to consider them. You have to have 3 equations, you have 3 unknowns. So you can consider the moment. For joints, you don't have to do the moment because they are particles. All the forces are going through a single point, but here they are not going through a single point, so you need to consider the moment as well. Can I give you a few minutes? Yes, finding T2 is the first thing that you can do. Why is that? You can do the moment as well, that doesn't matter. But if you do the forces in the y direction, what are the forces you have? T2 minus 10. Okay, so what is T2? Negative 2 divided by sine 37, right?
Minus 36.5.
Minus? So minus means T2 is the member AE. E is under compression. Okay. Are we all good with this? Okay. Now you can consider the moment, because x direction you can consider, but you have 2 unknowns, right? Yeah, because you still don't know how to identify zero force members. Okay, take the moment about this point is easy, right? Because you don't have any of these ones, right? Now, and also you don't have 10 as well. Why is that? 10 is going same line. So what can you say about T3? 0. Yes, you could have done it just by looking at this, but I have to have you already know how to identify zero load members or not? Okay, yes, so yeah, I'll tell you later on. So T3 is 0. Now you can consider all the forces in the x direction. So what are the forces in the x direction now? T1 plus T3 is 0. Okay, what else? Is equals to 0. So T1 is negative T2 cos 37. So it is negative 3.3 cos 37 positive value. So that means this one is under tension. What is it? T1 is your member AE. No. AB. Member AB is under tension. .6 positive kilonewtons and tension. Okay. Any question? No questions?
For this one, we can use moment, right?
You have to use moment because they are not particle questions. Particle questions means you have all the forces going. Joints are particles because they are just a point. Everything is going through that point. These ones, rigid bodies. There can be, you have to consider the moment. All good. Next question. Find the zero force members. Okay, so zero force members, the members, if it is zero force, member force is 0, you don't have to, structurally you don't have to have that member in the truss. But for aesthetic, to look nice, and also sometimes the loading condition changes, wind or something, so the 0, for the stability of the truss, we use 0 load members in the truss. So it doesn't say that we don't need it, but like, you know, depending on the situation, if the force changes or maybe for the aesthetic requirements to look nice, we will have it. So let's see how to find this. So these are the two situations. Okay, you look at the joints. When you look at the joints, so first one is this: at a joint, if there are only 2 members and no external force, then the 2 members are 0 load. So both the members, if there are only 2 members at a joint, and if there is no reaction force, so it can be an external force or else it, so you look at this one. So if you look at this one here, there are only 2 forces in this 2 members at this particular joint. Am I right? But there are no external force or a support reaction. So both these ones are 0.
Like there should be a support for that, but if there's no support,
No support or no external force applied on here. If there is, you can, when you have the truss, you can look at the truss member and truss every joint and see if you have any joint with 2 members only without an external force, then the 2 members are 0 load. Yes, in the first figure, if when you look at a joint, if there are only 2 members and if there are only 3 members, no external force, and 2 members are collinear. So you can see these 2 are collinear with each other along the same line. And this one has no load, so this is 0. In this, both of these ones are 0. In this one, that one is 0. So how you can you first, before analyzing the truss, you can figure out the 0 load members. Okay. Okay, anything else? Let's start. Now in this section we are going to discuss about internal forces on beams. Okay, so how to draw the axial force, shear force, bending moment diagram. Again, to select material and select the thickness and the critical points along the beam, we need to know the internal forces acting on the beam as well. So when we do one question, I will explain you more about these shear forces, bending moment, their positives and negatives, what that means, everything I will go through. Going to do the bending moment, shear force and axial force diagram for this particular beam. And again, if the support reactions are not given, here the AY and BY are given to you, but if it is not given, you have to consider the equilibrium of the whole beam, and you have to consider like, you know, you have to find it. You already know how to find the AY and BY, right? Am I right? Are you okay with that? So you consider the beam, and this is a pin and this is a roller. So you put the unknown forces and you apply the equilibrium conditions and you find this too. Good. Are we good with that? You want to find it by yourself?
Just keep going.
Okay. So it's given in this question. Now we are going to draw the bending moment, shear force, axial force diagram. That means the internal forces. First thing is, you need to section the beam and you need to find out where to section it. So you go along the beam and see, if you consider when you're going along the beam, this is where it is starting, and you have, when you go along the beam, you can see loading conditions are changing at these points. Am I right? So every in between, so you need to cut, first cut, second cut, and third cut. So you need to have 3 sections. So what are the 3 sections? When the x, so you are going to cut in an x distance. Okay, so you need to cut somewhere here where your x is more than 0 but it is less than 1.5. Any number between 0 and 1.5 is one section. Make sense? And again, when you cut here, your x is somewhere here. So your x is between 1.5 and 3. Am I right? Yes, 4.5. Am I wrong? And the next one is x is more than 4.5 and less than 6. Okay, so now tell me, if I cut somewhere here at first cut, and you can either consider the right hand side or the left hand side. I'm going to always consider the left hand side of the beam. So how can I draw this part? So I'm going to draw that part like this. That is the section. Only considering the left hand side. I have cut the beam somewhere here and I'm drawing the left hand side. So in the left hand side I have this 11.3. Am I right? That's all as external forces. Now I have the when we separate, there are actions and reactions. So if I say the other part of the beam is like this, isn't it? So I have all the other forces and everything here. So when I separated the beam, I have actions and reactions. So this is the axial force, action and the reaction. So you need to consider this. They always we put it is in a way that it will pull the two sides. So you can see this side also pulling, this side also pulling. Make sense? And the shear force. Shear force is always turning this in the clockwise direction. So this one is turning in clockwise. Do you see that? And this one is turning in the clockwise direction as well. So this is a sign convention. So you have shear force like that. Makes sense? And also you have the bending moment. Bending moment is always you put as this direction. Let me negative and positive. Let me check. I've forgotten that. Let me come back to this one. When you cut a beam, you have to have axial force. Axial force is always tensioning, as I told you, and shear force is always clockwise, turning the section in the clockwise direction, and the bending moment is in this direction. So it is making it compression in the upper. So you know when it bends like this, upper surface will be under compression. So always it should be like this. And also when you consider we consider sagging is positive, happy face is positive. You see the bend, if the beam is bended upward like this, we consider that bending moment is positive, happy face positive, and the angry face is negative. Okay, so that's how the sign convention works. So you need to put the directions in this way. So always we will consider the left hand side. So shear force going down and axial force coming out, and the moment is this direction. Okay, so all the time we are putting it in that direction. Yes, if you consider the left hand side, we always consider the left hand side. Shear force should be down, positive. Axial force coming out towards the right is positive, and bending moment this direction in the counterclockwise direction is positive in this one. Are we good? Okay, now let's move. Yeah. Yeah, I also forget sometimes. Okay, now let's come back to this question. So here we already mentioned that we need to cut. So loading condition is changing like this. So we are cutting at 3 sections. When the x is 0 and 1.5 is 1, and when the x is more than 1.5 and 4.5 is 1 section, and the other one is x is more than 4.5 and less than 6. Okay, and we are going to draw the left hand side of the beam. So sometimes these ones will be given to you, but if it is not given to you, how do you identify where to make the cut? You go along the beam and you draw a line and see where the loading condition changes. So when you go 10 kilonewtons, 15. So you have to make the first cut here, second cut here, third cut here. So first one is between 0 and 1.5, second one is between 1.5 and 4.5, and the third one is between 4.5 and 6. Make sense? Okay, so now we are drawing the left hand side. You can consider the left hand side or the right hand side. There is nothing wrong in that, but always do one method, okay? Then you don't go wrong. So I normally do the left hand side, equilibrium of the left hand side. So if you draw the left hand side, this one is 11.3, and do you remember the signs? N is this way, V is this way, M is this way, right? And the next section, how do you draw this? You have 11.3. What else? Now you have a 10. Do you agree? And that is in 1.5 meters. Am I right? Again, you have your N, V, and M. Wherever you do the cut, you have these three: shear force, axial force, and the bending moment. Now the next one. Next one will be what? You have this 10, and also you have a 15. Make sense? And you have 11.3, and you have N, V, and M. Makes sense? So this finding this V, N, and M that is what we need to do. I'm going to do one, and I want you to do the rest. Now can you tell me how much is this length? We are we are cutting at how we are cutting from here x distance. We are cutting at x distance. So this is x, and this is x, and this is x. X can be any number between 0 and 1.5 for the first section. X can be between 1.5 and 4.5 for the second section. X can be between 4.5 and 6 for the third section. Makes sense? So that length is x. It can vary. Are we good? Now if you consider the equilibrium of this section, so I'm going to do the first one. If you consider all the forces in x direction, N is equals to 0. Am I right? Is that right? That's the only force in the x direction. I'm just considering this part. I'm just considering this part. Now tell me what is, if you consider all the forces in the y direction. All the forces in the y direction. What do I have? 11.3. Yes, you consider the equilibrium of that section. What's that? V is equals to what? Yes, V is equals to 11.3. Am I right? Now you take the moment, always take the moment. You can take the moment about any point, but take the moment of the left-hand corner. So this point A. If you take the moment about A, it also should be equals to 0. Am I right? So take the moment. How do you write the moment? Is 11.3 is making any moment about A or not? This 11.3, it's going through A, isn't it? So no moment. Am I right? But M is, there is a couple moment, M and minus Vx. V times the perpendicular distance is x. N is again going through A. So this is equals to 0. So your M is equals to Vx. Agree? Agree? So V is what? 11.3. Am I right? Is that right? What's that? I didn't get you. What's that? Yes, yes. So you can put the 11.3 here.
Yeah, but this V is going down, so that should be y, the y-axis.
Yes. I'm taking the moment. So I'm taking the moment about this. So this V times the x. Moment is force times the perpendicular distance. X is this x. Okay. So this is 11.3x. Am I right? So what are the boundary conditions? It is changing from 0 to 1.5. Am I right? So when the x is 0, your M is 0. Am I right? Is that right? When the x is equals to 1.5, what is it? 1.5 times 11.3? 16.95. Okay, now see here. Now you can draw the axial force, shear force diagram only for this section. So axial force diagram.
So we need to draw for like for each and different.
Yes, yes. So this is the bending moment diagram. So if you draw the axial force, it is 0. Shear force, what is happening? Constantly it is 11.3. Bending moment starting from this and going to 16.95 kilonewton meters. Am I right? Is that hard? No. Can you find me the second one, please? Find the N, V, and M for the second section. Positive or negative, it depends on what direction you consider. You consider upward positive, right? Normally, if you consider upward positive, 10 is down. So N is 0, that is obviously N is 0. So if you consider all the forces in the upward direction, you have 11.3 minus 10. Why the minus 10? Because it's going down. Look at the direction, positive upward. And this is also down, so negative V is equals to 0. Makes sense? So what is your V in this case? 1.3 kilonewtons. Okay. Now find me the M. So I'm deleting this too, otherwise we don't have. Okay. All right.
So again is equal to m minus vx is equal to 0.
No. So you are taking the moment about this point, right? So you have 10 times 1.5. Do you see that? M is there. M is counterclockwise, isn't it? So positive minus 10 times 1.3 plus or minus Vx is equals to 0. So M is equals to what? 15 plus Vx. Did you get this? So what are the boundary condition in this case now? X is equals to what?
We take 1.5.
1.5 and X is equals to 4.5. So these are the two boundary conditions for that section, isn't it? So what is M?
Is 16.5.
16.95. And here? 15 plus 1.3 times 4.5.
We are also taking.
V is 1.3.
That's 20.85.
What's that?
20.85.
How do you draw it now? This is 0
Yeah.
and this is 1.3 and this one is going like this.
Yeah.
And this is 20.85 kilonewton meters. Okay, next one. Next section. Okay, so let's see. V should be now 11.3 minus 10 minus 15 minus V is equals to 0, right? So V is equals to 11.3 minus 25. So what did you get?
Minus 3.7.
Minus 3.7. Okay. Now the next one. Moment about point A. So you have M minus 10 times 1.5, right? Minus 15 times 4.5.
V should be minus 13.7.
How come?
Another constant minus 25.
Yes.
I think minus 13.7.
Okay. Yeah. Yes, 13.7. Yes. That's right. Yes. 25 minus 11.3 is 13.7. Yes. And then you have minus Vx is equals to 0. So now you can make the M the subject. You have 15,
Plus Vx.
82 point.
5 plus Vx.
Vx, yes. So Vx is negative. So you can say m is equals to 82.5 minus 13.7x. Okay. So this is your equation, and you put the boundary conditions. Your boundary conditions, when you put 4.5, it is 20.85. Am I right? And when you put 6, it is 0. So your bending moment diagram is going like this. Makes sense? And the shear force diagram is down here, 13 point something. And axial force is 0.
On the 20.85 again.
What?
It's 20.85 again for the.
Yes. And yes, 6 is 0. When you put 6, you get 0, right?
Yeah.
Okay, so it's going like this. So do you see the diagram? We have drawn the diagram, and it didn't take much time, and it's not hard.
So this one, for the part 3, the M should only get one answer.
M should only get?
One answer. Like the part 2 had got 2 M.
No, 2. You have to put and see when x is equals to 4.5 and when x is equals to 6. Put the numbers and see. Yes, 6 times 13.7 is what?
0.3. No.
13.7.
No, it's 13.7 times 3. That's 82.2.
Yeah.
Okay. Yes. So I think we have rounded off something. Otherwise, you should get 0. Double check your 80, because we always 13.7 is not the like maybe. Okay. Maybe our 20.85 is not exactly 20.85. Well, 1.3 times 1.3 times.
It should be 0.
It should be 0 because, like, there is no moment at the end. Maybe we rounded off or something. Otherwise, it should be 0.
If it doesn't come 0, then
You have 0.2 or something, right? Just 0.2. That is because of the rounding off. Otherwise, yeah, it's just you can double check.
So when you exam, the answer should be 0.
Depending on what you have in the next question, I'll show you. Next question, it doesn't go to 0. If there is a moment here, you have to get something. But in this case, you don't have a moment here. You don't have a moment here and here. So it should start at 0 and ending at 0 for this particular question. If you don't have moments at the two ends, yes, 0 starting 0 ending 0. But if you have a fixed support or maybe a couple moment applied, then it is not 0. Make sense? Oh, good. Okay. Now let's do another question. Read this question. It's long. I want you to first find the support reactions, please. Here, what do you have? What support you have? Fixed support. So how do you replace? How do you draw the free body diagram? How many unknown forces for a fixed support? Fixed support is how many unknowns? Roller is 1, pin is 2, fix is 3. So what you have? You have AX, you have AY, and also you have an M. So can you find me these 3? This we call the free body diagram. We take the beam out and we put all the forces. Replace the supports by reactions.
In this question, the AX should be 0.
Yes, AX. Mostly in beams, we have only lateral forces. AX is 0. But in case if you have a force like this, then AX won't be 0.
Why x is 0?
Because you don't have any force in the horizontal direction. Yes. Normally beams are like that. But in case if you have a slanted load, AX. AY should be 6, yes. Yeah, find me those 3.
And is equal to 6 times 3.
Okay, taking the moment about this point, right? So M minus 6 times 3 is equals to 3 equals to 0. So M is equals to 18. Okay, are we good? Okay. Okay, now I'm going to put all this there. In case if one of these is negative, your arrow is opposite, okay? So if you assume upward but you get a negative, that means you have to put the arrow down. And you have a moment again positive, which is 18 kilonewton meters. Okay, so we have found that. Okay, now how many sections we need to do? How do we recognize that? How can we find that? You start from the end and you go along the beam where the loading conditions are changing here. So you need to do only one cut. Make sense? Where you need to cut again then? Where? X, it is the X can change. Do you have anything happening here? Any load or anything? No. So you look, you go along the beam and you only cut it if there is a changes in the loading condition. So when you go here, nothing changes, no loads, just up to here. So you need to cut only when between this 0 and 3 meters. Make sense? And you consider the left hand side. When you consider the left hand side, don't consider the right hand side. There is nothing wrong, but get used to one method, then you don't go wrong. So what do you have here? You have 18 kilonewton meters, you have 6 kilonewtons, and you have N, you have V, and you have your M. And can you find me these ones, please?
So we're going to take a value from 0.1.5, 0.
For what? For what?
So, like they already mentioned that we're only going to take one 0 to X, then 3.
X can be between 0 and 3, any number, because like you don't have any changes between these. If you have something, yes, you need to have. If you have a load, for example, if you have another load here, in that case you need to do 2 sections, with the load and without the load, before the load and after the load. But here nothing changing. N0, yes. V is 6, and taking the moment here. So how do you take the moment? 18 plus M, am I right? You need to consider the 8 and don't consider the, this is a couple moment, okay? So even though it is acting at A, you can't ignore the 18. It's a moment, okay? 6, yes, because perpendicular distance is 0. And then you have minus V times X, because you are cutting at an X distance. Make sense? 0. So 18 plus M minus 6X is equals to 0. So your M is equals to 6X minus 18, right? So what are the boundary conditions? When X is equals to 0, M is equals to minus 18. And when X is equals to 6, your M is equals to 0. No. 18 plus 3. Sorry, this is 3 now. X is between 0 and 3.
Yeah.
Isn't it? Yeah. So how do you draw this one now? Let's draw. Normally we draw it underneath the beam, so it is easier. When the X changes, we can find out. Okay, so N is 0. Axial force is 0. Shear force is 6 constant. And the bending moment is negative 18 to 0. Okay? Negative 18 to 0, right?
This part is for the cut. After we cut this graph. So we don't consider about the first 18.
You can't cut before the beam. You have to cut the beam.
Yeah,
Before the beam, like before the beam, like you can't have a cut somewhere here. You need to have after somewhere here.
So I mean the graph we draw about the after we cut it in 0 to 3.
Yes. So when the X is 0, that means this point. No, am I right? X is 0 means this point. When the X is 0, you got negative 18. So this one is negative 18. When the x is 3, you got 0. Okay. So, and I forgot to tell you in the previous one. So here you have a why. Let's see why we need this internal force diagram. So in the previous one you saw something like this, isn't it, for shear force. So you can see which sections your shear force is higher and critical, and you don't have to have the same thickness of the beam throughout. You can find out only this section undergo this much of a shear force. This section is less, this one is higher. So likewise you can select the section size without wasting your material. If you know the internal forces, you can wisely find the material and the section thicknesses, because everywhere is not the same force acting, isn't it? So you don't need to waste. And also here you have a negative bending moment. Negative, I told you, negative bending moment means, I'll show you here. When you have something like this we call a cantilever beam. This one bends like this, isn't it? Because of this force. It's hogging. I told you, if a beam bend like that, angry face is negative. So you can see negative. This is hogging. Hogging means in a concrete beam you have to put the steel reinforcement at the top. Why? Concrete only can take compression. The top of the beam is tensioning, isn't it? When it goes like this, top is tensioning, bottom is compressive. So you need to put the reinforcement at the top. If you don't do this one, you will put the reinforcement in the wrong place. Then the beam can't survive, isn't it? And in the previous one especially, some parts are going on hogging, some parts are positive. Positive means it's bending like a happy face. So in these sections you have to put the reinforcement at the bottom. Makes sense? So it's really important to know how the bending moment diagram, shear force diagrams and axial force diagrams work, and what are the critical points, whether they are positive or negative. Otherwise we don't know where to put the reinforcement, which material to use, and also which sections are critical. To find all that, we need to know the internal forces. Are we good? Okay.
Can you please go to the last question?
Yes. 3D, actually, I think you had 3 weeks, 8, 9, and 10, 3 dimension. You have learned 3 dimension in 3 weeks. I think bending moment you did only 1 week, week 7. Okay, let's see. Okay, so here, first thing in 3 dimension is to identify the coordinates in 3 dimension. So it's like the 2 dimension, but you have an additional axis, Z axis. So here in this question they have given us the coordinates, so we just use them and find the answer. So here they are asking us to, in the diagram for Cartesian coordinate system, A is the point with coordinate this, B is this. Write the position vector AB. Okay, so we should know how to write this vector starting from A and going to B. Writing a vector means you are going to write it like with the with unit vectors. Do you know? Yes, so in the x direction you have unit vector I. I means it has the direction of x, but the magnitude is 1. And in the y direction you have j, and the z direction you have k. Okay, so when you say RAB, you need to do B minus A. So you have 3 minus 4, isn't it? X component is 3 minus 4, that is negative 1i. Why I? Because it's in the x direction. Then you have plus, what do we have? 7 minus 6, which is 1j. And then we have plus 7 minus 2, which is 5k. So you can write it as I plus j plus 5k. So that's what they are asking you to do. Are we good? Okay, this one we call the position vector. If I ask you to find the magnitude of this AB, how do we find the magnitude? Do you remember?
Root of the square.
Yes, so you have negative 1. In front of this one you have negative 1 squared. and in front of this you have 1 squared, and here you have 5 squared. Taking the square root of this, that will give you the magnitude of the AB. Can you find me that, please? Okay. Yeah. You write. Where is the attendance book? Did you write your name?
Yep.
So 5.2.
5.2. Okay, so this is the position vector and this is the magnitude of the position vector, and there is another thing called unit vector. Unit vector AB is what? How do you write that? AB you divide by the magnitude. What do we mean by a unit vector? Sorry. What do we mean by the unit vector? Unit vector is along AB, along the AB, 1 unit length is 1. Okay, so how do we write this? Yes, minus 1 over 5.2i plus 1 over 5.2j plus 5 over 5.3k. This we call the unit vector, and if you find the magnitude of the unit vector, you should get what? You should get 1, because the magnitude of a unit vector, the meaning of the unit vector is it has 1 magnitude, so this should be 1. Make sense? Okay, so in this question what we learned how to find the position vector, how to find the magnitude of the position vector, and how to find the unit vector. Are we good? Okay, I'm moving to the next question. Do you need time?
I think we also need to find out the angle.
They don't ask anything yet. You can find the moment as well here. But let's do it later on, okay? In this question, actually, they are only asking us to write this one, and we did a few more things. Let's go one by one. In this one, in the diagram, the vector from A point towards B is represented by a Cartesian vector. So VAB is given to us. The force is 40, and they are asking us to write the force F in terms of F as a Cartesian vector. So do you remember this part? I told you how to do this. So how do we do this one? How do you write F as a Cartesian vector? That means something times I plus something times j plus something times k. How do you make it? This is magnitude is 40. So how do you convert it to that? You remember how do we do that? U times 40 by the unit vector along AB. Do you remember that? Okay, now I already told you how to find the unit vector. Can you find the unit vector? And this one is given to you, but this is not a unit vector, isn't it? This is just a vector. So how do you make it to a unit vector? You divide this by the magnitude of this. Can you find me the UAB and also force? And then we can do the moment.
So we just find the magnitude and we find U times by
40.
That's it.
That's it for the, yes, for the force.
Yeah, 40.
Yes.
Oh, this one.
Yeah, I'll give you time, okay?
Magnitude is 9.1.
Magnitude is what?
9.17, which will be 9.2.
Okay, 9.2 magnitude, and you need to have 2i plus 4j plus 8k. You divide by this. So did you find the force? What times I? 40 times 2 divided by 9.2. 8.8i. Okay, do you all get this? 8.8 I, 17.6 J, 35.2 K. Are we good with finding F?
That's for the moment if we want to find.
Yeah, moment I'll do it in a different question because I'll where the what we call coordinates are given, we'll do a question with the moments later on. Okay, I have another question. Okay, finding the force when the magnitude is given to you, and if you know the direction of the force, finding this one, are you okay with this? Finding the force in Cartesian form. So if they ask you to find the force in the Cartesian form, this is what you need to do. Make sense? Okay. Now this one. I want you to find the okay. Yeah, let's do the moment with this. Okay. I want you to find the position vector AB, and let's say this force is magnitude of the force is maybe take let's say 40. Force is 40 newtons. Okay, and along the AB direction. I want you to find the force in the Cartesian form, and then we will do the moment. Last one, you don't have the points, so no, it's not hard. Without the points, you get confused to find the moment. Okay, so your questions are always with the points, so it is easier for you to figure out the moment. So we'll do the moment with this one.
Last time you said
Yes.
that's why I said last time you didn't do that.
Last time with that part we didn't do, but yeah, we'll do this one with the moment. Okay, I want you to find the force in the Cartesian form. Force is along AB. Okay, force is from A to B. B is 532, A is 123. So how do we find the position vector A to B? How do you find it? B minus A. So that will be 4I. Okay, yes. So then you need to find the unit vector AB. To find that, you need to find the magnitude of this. That will be 4 squared plus 1 squared plus 1 squared. What's that? 4.2. Okay, so your U, this one will be now you can find the force. You just times this by 40. Now 40 divided by 4.2, no, yeah, 9.5 should be fine. Divided by 4.2. Yeah, so this looks okay. Okay, so this is your force. Am I right? Okay, now we are going to find the moment of this force about the origin. Okay, moment is always force and the distance times the distance, isn't it? But in the 3D, this is the cross product. So this direction also a vector. It's not just the distance; it is a vector, the direction. So you can you need to find the moment about this point. Your direction can be OA or else OB, doesn't matter which one you consider. Okay, so your moment is all the time the distance, so the distance times distance cross the force. Okay, moment about O. Okay, so you can either say OA cross F or else OB cross F, both okay, because anything along the line of action of the force, if you extend this one, any point, any O, B, A, C, D, wherever it is, it doesn't matter. You have to find a point along the line of action of the force. If you know a point along the line of action of the force, that cross F will give you the moment. So this is a cross product. So it gives you a vector. So you have to use the determinant to find this. How you do this is you first need to write IJK, then you write the OA. OA means what? O to A minus O, isn't it? OA vector is equals to I plus 2J plus 3K, isn't it? Am I right? A minus O, no, O is 0. So you have to write whatever you have in front of these ones next. 1, 2, and 3, right? Then you write the cross F. So 38.1, 9.5, and 9.5. Am I right? Yes, sorry, minus 9.5. Yes. Okay. So up to here, any question? How we expand the determinant? Do you remember expanding determinants? Yes, so you have plus minus like that. So you have a plus minus plus.
Always plus minus plus.
Plus minus plus. If you have a longer, bigger one, again plus minus going like that. Okay, so I'm going to do 1. So if you consider the I, you ignore this 2. So you have I times this 2 times negative 9.5 minus 3 times 9.5. That is your I component. Am I right? J will be a negative J. So you have a negative here. So you ignore this 2. Then it will be 1 times negative 9.5 minus 38.1 times 3. Makes sense? Then you have positive K times, ignore this 2, 1 times 9.2 minus 38.1 times 2. Am I right? Which one?
1 times 9.5.
9.5, yes. Yes. Okay. So can you find me the moment now? Moment is a vector. It has something times I plus something times J plus something times K. So what do you get?
Minus 9.5.
Plus. I mean, yeah, minus.
5 times 9.5, right?
Yeah.
5 times 9.5.
Minus 48.1. 48.
Minor.
What's
It
that?
should be minus 5 times 9.5.
Yes, minus 5 times 9.5 is what? 50 some 40 something. 48 point.
Minus 48.
Oh, it's 47.5.
That's better.
Oh yeah, 47.
Yeah. Minus.
You know, in our days, we couldn't use the calculators. We have to use the logbooks. You know, olden days, still we had to find the final answer with the log books, and log, when we convert to log, and we took the, like, all the multiplications we converted to addition using addition, no subtraction, using the log book. You guys are so lucky, but still you are going wrong.
Yeah, no. I used the paper copy for 10 years.
Nowadays you divide using the calculator by 10. Am I right? So it is 47 point. What's that? Okay, J is what? So you need to consider there are negatives. This will become a positive value, right? So J is a positive what? Negative will become positive.
Minus 100.
I think I should be 48.1. I should be 48.1.
It cannot be 48. I remember it's not 48. Because 40 times 9, 0.95. It cannot be 9.
You're talking about I?
Yeah.
It's talking about that
9.5 times 5 is 47.5. Yes. Next one is 9.5. Yes, plus 38.1 times 3. It is 100 and positive, right? It will become positive. Am I right? 123.8 J. And the K will be, yes, 38.1 times 2 minus 9.5, which is negative 66.7 K. So we found the moment. Again, the moment is a yes, moment is a vector.
I think should be 9.8 over here.
Well, 9.5.
Yeah, no, I'm saying that it should be 9.8 over here. I'm not sure.
This is 9, both the same. I can't remember. I erased. Is it 9.5?
Yeah, it's the same thing. Yeah, same
Both,
9.5.
both should be the same. You remember this is
Both
1, 1.
1.
Yeah, 9.5. It's my error. I wrote 9.2. 9.5, right?
Okay.
In both. Sorry. Yeah, it is 9.5 for both. Okay, so we know the method now. Even the numbers are wrong, you know how to do it, right?
9.5 is 1 over 4.2 times 14. It should be 9.5.
Okay.
9.5.
Yeah. 4.2 times 4, divided by 4, yes. 40 divided by 4.2, yes. Okay, let's go to the next question. Okay, how do we do this? Angle between, this is dot product and cross product. So you have an idea of cross product now. Dot product, yes. So dot product is a scalar, not a vector. So dot product we use to find two things. One is to find the angle between two vectors. So if you want to find the dot product of these two, so A dot B, you can write it in two ways. First one is you can say 12 times 3 plus 2 times 7, negative 7 plus negative 3 times negative 2 is your dot product. This is one way of writing the dot product. Yes, minus 12. Okay, so what do we get when you put this? So this is minus 36. Okay, so
No.
tell me the answer. So what is A dot B? Minus 36 plus, no, minus 14 plus 6. Okay. 30 plus 14. 44 negative is your A dot B. So this is A dot B. That's another way of writing A dot B. How do we write the A dot B? A dot B is A magnitude times the B magnitude and the angle between A and B. Okay, so how do we find the A magnitude? Negative 12 squared plus 2 squared plus 3 squared, square root of this. Am I right? How do we find the B magnitude? 3 squared plus 7. You don't have to put the negative because it is squaring. Am I right? Square root of this. Am I right?
Yep.
Okay, now you can say these two are equal. Am I right? So A, B cos theta is the dot product, and also negative 44 also the dot product. Am I right? Is that right? So you make the cos theta the subject. Negative 44 divided by, find these two and put them here, and you can finally find the theta. Cos inverse negative something. So can you find me theta, please?
Fine.
116.5 degrees. Okay.
Should be minus 44 divided by 8 times B. Right?
A is what?
It's 12.5.
B?
7.9.
Okay. Yeah, cos inverse this. Are we good? So we can use the dot product to find the angle between two vectors. Now we know how to find it. Any question? Other thing that we can do with the dot product is finding the component of a vector on another vector. So you know how to find the components in 2 dimensions, right? Component is you maybe you find, how can I explain it? It's like the shadow on another direction, isn't it? So if you have finished this, I can explain it as well with this too. How to find the component of A on B. Have you done this? Finished? Can I move on? Okay, now what we are going to do is we are going to use the same two values here, A and B, and we are going to find the component of A on B. So we can only find the magnitude of the component of A on B. Okay, to find that component of A on B is equals to, component of A on B is equals to A dot the unit vector of B. Make sense? Is that clear? What is A? A is this. Unit vector of B is what? You divide the B by, yes, which is already found, 7.9. And if you consider the dot product of these two, how do you do the dot product? Dot product will be minus 12 times 3 over 7.9. Am I right? Plus 2 times negative 7 over 7.9. Am I right? And then the next one is negative 3 times negative 2 over 7.9. So when you put, they're all numbers, it's a scalar. When you put this in your calculator, you get a number that is the magnitude of the A, or the component of A on B. Clear or not? So we have done 9 weeks in one day. I hope you digested.
That should be.
For the next week.
I will give you a paper for you to do in the class, and if you go wrong, I can't say exact. In a way that it covers the questions in that part. Okay, and let me see whether this is done or not. Yeah, it's yes. Or if you do all the tutorials, your exam is much easier than your tutorial questions. The thing is, you forget. That's the thing. So this part I already did. Do you want me to do it, or are you okay? So this one they ask to calculate the component of f in the direction of r. Do you want to do it, or are you okay? The same thing. How do you do that? That will be f dot ur. So do you know how to find ur? You divide this by the magnitude. 3 squared plus 4 squared plus 12 squared square root of it. That will be your ur. Then you take the dot product of these two. Make sense? The same thing. Yeah, this one is important. I did this once, but if you can do this again, there is a question like this in your paper. So can you try this, please? This has everything. Like, your question has many parts like that. You have 2 questions in the final exam from 3 dimensions. It's a bit hard to make it bigger, but I'll put the numbers, okay? So this is 10, and this is 1000 newtons. This is 12 meters, and this one is, even I can't see that, 5. Yes, this is 5. Now, I think it's good, right? And the arrow is this way. Okay. Coordinates of the point A and B. What are the coordinates of point A? 0, 0, 12. Agree? All agree? No, it doesn't have ijk in the coordinates, okay? Yeah. So B is what? Along the x, this is your x, this is your y, and this is your z. 5, 10, and 0. Okay. Now your force is from A to B. So what is AB? 5I plus 10J minus 12K. Are you all okay with this? Okay, so you have found the position vector, you have found this. Magnitude of the position vector. So how do we find the magnitude of this one? 5 squared plus 10 squared plus 12 squared square root of this. Can you find me, please? What's that?
Yeah, 16.4.
16.4. Okay, there. Now the unit vector, this part. Unit vector UAB. How do you find the UAB? 5I plus 10J minus 12K you divide by 16.4. Am I right? Now coordinate this part. Coordination directions we didn't do here. I explained you last week. What do we mean by coordination directions? Do you remember coordination directions? Alpha, beta, gamma. Remember? Alpha, beta, gamma. And they are the angle making with x is alpha, angle making with y is beta, angle making with z is the gamma. So how do we write the cos alpha? X component, whatever you have in front of x, divided by x squared plus y squared plus c squared square root of this one. In this way, you can use this AB because it's the same. AB or unit AB is the same direction, angle is the same. So you can say 5 divided by 16.4. Agree or not? Because this is 5 and the magnitude is this. So what is alpha? Alpha is cos inverse 5 over 16.4. You can find the alpha angle. So if you want to find beta, beta will be cos inverse 10 divided by 16.4. Gamma will be cos inverse negative 12, okay? Negative 12 divided by 16.4. So you can find alpha, beta, gamma. Any question? What is the relationship between alpha, beta, gamma? If you know two angles, you can find the third angle. What is the relationship between these three? Cos squared alpha plus cos squared beta plus cos squared gamma is equals to 1. Okay, remember that. Cos squared alpha plus cos squared beta plus cos squared gamma is equals to 1. Because your numerator will become x squared plus y squared plus z squared, and bottom also that. No, in this one they don't ask you to find the relation, but we only have to find alpha, beta, gamma, and we found it. Are we good? Okay, now then we need to find the force in the Cartesian form. To find the moment, we first need to find the force now. So how do we find the force in the Cartesian form? Yes, so they are saying the force is 1000 newtons, and you times this by unit vector. You already know the unit vector. So you have something times I plus something times j plus something times k. Make sense? Are we good? Any question?
This question didn't ask for the alpha and the angle.
It asks coordination directions. Coordination direction means alpha, beta, gamma. You need to find it.
Now we are finding the moment in 3D.
You need to find the moment in 3D. Before the moment, you have to know the force, because without knowing the force, you can't find the moment, isn't it? Even though it doesn't say, we need to find the force. Make sense? Okay, so how can you find the force and then find the moment? I already told you how to find the moment. Moment about O, you can consider OA, yes. O else, OB, doesn't matter. Any point along the line of action of the force. Done? Okay, so you have, I'm not going to write it, okay? So you know how to do that. How do you find the M? M will be I, J, K. You can use the A, is easy, 0, 0, 12. Am I right? And this one, whatever you get, okay? And you expand the determinant and you find the moment. Moment again, a Cartesian vector with I, J, K. So you need to remember when you are expanding, plus, minus, plus. And yeah. All good. So it covers everything in your final exam.
You can't take B.
You can take B, yes, you can. But it will be different, but your answer is not wrong. Slightly, it can be. You can do that as well. Any point along the line of action of the force is fine.
Wait, can I ask
All
a
good?
question?
Okay, any question?
Yeah, okay. So in this question,
Yeah.
at first I found this one f times
Yes,
1000, and I get AGK.
Okay.
And I put
Those
number
numbers, yes. So if you have minus, you need to put minus,
Yeah.
70, yes. You put them and you expand them.
Okay.
Okay. So let me see what else I have.